Today we're going to talk all about the polygons, and we'll talk about the quadrilaterals in detail, but we're going to hit all the polygons today. And we're going to start off by talking about some definitions. Of course, a polygon in general is a many-sided figure. And we've already talked about the triangle. Of course, the triangle is that three-sided figure that you're all very familiar with. Quadrilaterals are the four-sided figures. Pentagons are five-sided figures. Hexagons are six-sided figures. Heptagons are seven-sided figures. Octagons are eight-sided figures. Decagons are 10-sided figures. Dodecagons are 12-sided figures. And of course, there is a name for the nine-sided figure and for the 11-sided figure. And for 13 through 19, just to show you that there is such a thing, there is a 20-sided figure called an icosagon. A lot of times we'll refer to these odd, and by odd I don't mean odd number, but odd as in not usual. Um, we'll call them like a 23-gon. And a 23-gon, of course, is a 23-sided figure. So a lot of times you'll see that that sort of notation. Just want you to be familiar. And next we'll talk about the different types of polygons, a couple of different types of polygons. We have the convex polygons and the concave polygons. Convex polygons, there are no diagonals that lie outside of the figure. And you can see here, this is in this green pentagon is a convex polygon, and you can see I've drawn all of the diagonals and all of them lie inside of the polygon. And here I have this red polygon over here. This is a concave polygon, and you can see quite clearly that this diagonal here lies outside of the polygon. And of course, here's diagonal, definition of diagonal. Diagonal is a segment that connects two non-consecutive vertices. Consecutive, of course, means one after the other. So non-consecutive would mean not one after the other. And you can see this diagonal here goes from this vertex to this vertex, and those are non-consecutive because I skipped this vertex here. And then we have a polygon, and we sometimes describe some of the polygons as being regular polygons. And regular polygons, all of the sides are congruent and all the angles are congruent. So if I were to draw this pentagons a little more accurately so that all five of the sides were equal and all five of the angles were equal, then we would say it is a regular polygon. And we'll continue discussion about the angles of the polygon. Here I have a hexagon. It looks as if some of these angles are a little bigger than others, so I would say it's not a regular uh, hexagon. And let's pretend that I tried and did and was able to draw a regular hexagon such that all of the angles are congruent and all the sides are congruent. Well, if the if all the angles are congruent, then if I added them up, all right, I would have the sum of the measures of the interior angles of that polygon. And that is always going to equal 180 times n minus 2. And n, of course, is the number of sides. So here my six-sided figure would be 6 minus 2, or 4, times 180, which is 720. So the sum of the measures of the interior angles of a hexagon is 720 degrees. Well, the measure of one of those interior angles will be 180 times n minus 2. That's the sum of all of them divided by however many that there are. So if I take 720 and divide by 6, I would find that each of these measures, each of these angles would be 120 degrees, these interior angles. All right, and I've tried to show you an interior angle in here, just definition wise. These are the interior angles inside here. Well, if these are the interior angles, then this angle here would be an exterior angle. And there is an exterior angle at each of these vertices, but I've just drawn this exterior angle right here. Well, if I took all of those exterior angles and added them together, the sum of the measures, the exterior angles of every polygon is 360 degrees. Always, always, always. And the measure of one exterior angle would be 360 divided by n. And if n is the number of sides, then in here for the hexagon, that would be divided by 6. That would mean that each of these angles, each of these exterior angles is 60 degrees. Well, let's think about that for a second. I've got an interior angle that's 120 degrees, and I've got an exterior angle that's 60 degrees. Well, guess what's true about those two angles? Yes, indeed. They form a straight line, they are a linear pair, and they are supplementary. Now let's talk a little more in depth about these quadrilaterals, these four-sided figures. The quadrilaterals, and I've got a little chart here, the quadrilaterals are broken down into three types. We have the kites, the parallelograms, and the trapezoids. Well, kites are quadrilaterals that have two pairs of consecutive congruent sides. And that's why they're sort of off to the side. They're unusual. Trapezoids, there's only one pair of parallel sides in the quadrilateral. And they're unique also, so they're sort of in their own category. But the parallelograms, all right, are the quadrilaterals where there are two pairs of parallel sides, and that's why they're here in the middle, because there's other types of parallelograms. These parallelograms again have two pairs of parallel sides. Well, these parallelograms break down into two different types. We have two different types of parallelograms. We have the parallelograms that have four right angles, and we call those rectangles. We have the parallelograms that have four congruent sides. And if it is a parallelogram that has four congruent sides, we call it a rhombus. And then we have the parallelograms that are both rectangles and rhombuses. They have four congruent sides and they have four congruent angles. And so these squares are always, all right, going up the chart, these squares are always rhombuses. These squares are always rectangles. Squares are always parallelograms. Squares are always quadrilaterals. Rhombuses are always parallelograms. Rhombuses are always quadrilaterals. Rectangles are always parallelograms. Rectangles are always quadrilaterals. Kites are quadrilaterals. Trapezoids are quadrilaterals, and parallelograms are always quadrilaterals. So as you go up the chart, it's always true. As you go down the chart, it is sometimes true. Some quadrilaterals are parallelograms. The only quadrilaterals that are parallelograms are the quadrilaterals with two pairs of parallel sides. Quadrilaterals are sometimes rectangles. The only quadrilaterals that are rectangles are the quadrilaterals that have four right angles. And I could continue on, but let's do one more. Parallelograms are sometimes squares. The parallelograms that are squares are the parallelograms that have four congruent angles and four congruent sides. So we'll work more with this chart. And we'll work more in depth with all of the polygons that we've discussed in this video.